Okay, here's the diagram for 94, and what I've done is I've gone ahead and worked out the solution, and I want to kind of walk you through it, and then what we may do is do a little replacement problem for you for this one that's similar to this with different values, and I'll send that to you tomorrow. Same setup, just with a different point. So for 94, we want to find the length of the hypotenuse of the right triangle as a function in terms of x. So the first thing that we need to do is to find the length, we're going to have to use the distance formula, and we want it all in terms of x. Well, right now, the two endpoints, x0 and 0y, are x and y intercept. One's in terms of x and the other's in terms of y. So we need to get the y-intercept written as in terms of x. To do that, we need to find the equation of that line. So the first thing we need to do is find the slope. To find the slope, I'm going to use the 2 points, the one point that I know is on the line 3, 2, and the x-intercept, which is already in terms of x. So using the slope formula, changing y over changing x, 2 minus 0 over 3 minus x, which simplifies to 2 over the quantity of 3 minus x. Now, we're going to use that and plug it into slope-intercept form of the equation of the line, because our whole goal is to go back up and find the y-intercept in terms of x. So I come down here, use slope-intercept form, and you could do this in a variety of ways. You don't have to use slope-intercept form, but our goal is just to solve for the y-intercept in terms of x. So I use slope-intercept form. I plugged in the slope from above, y equals 2 over the quantity 3 minus x times x plus b. I knew that that point was on the line 3, 2, so I plugged in the point 3, 2, 2 for y and 3 for x, and simplified. Since that's a fraction, we're just going to multiply on top with the numerator, which leads me to this right now. 2 equals 6 over the quantity 3 minus x plus b. Then we can just subtract that quantity to the other side and solve for b. B is going to be the y-intercept, and that is 2 minus 6 over the quantity 3 minus x. So I can really write that as a point. It's kind of messy, but it can still be written as a point. So now I have 2 points that I want to find the length between, and I only have one variable now. Instead of having x-intercept x0 and y-intercept 0y, now I can use x0 and then plug in the b value, which I just solved for over here. So to come back, now I have those 2 points. Now, all I want to do is find the distance between those 2 points. So I can use the distance formula. You could use Pythagorean theorem here, but that's going to just be, Pythagorean theorem and the distance formula are really the same thing. So distance formula works here as well. So I came down here and wrote my function of x using the distance formula, and now I plugged in values. x2 minus x1, y2 minus y1, simplified. Negative x squared is just going to be x squared. And then over here, you subtract 0, you have that quantity. And that's really all you have to do. Now you've met the goal of having that function. There's really no need to expand that quantity on the right, because it's not going to help you as far as simplifying anything. So it's in good shape. So that's as far as we have to go. So now we have the length of the function, now the length of the hypotenuse written as a function of x. So that's where it's at. So it's a little messy, but once we get into it, it's not really that bad. But it is kind of a messy start. So I tell you what I'd like for you to do. I'll go ahead and tell you now. Why don't you do another one for 94 and submit it to me, and I'll grade it. And that's, let's use the point 5, 2. Okay? Shouldn't be that bad. Okay? Hope this worked. If it didn't, let me know. I can take an image of this, but hopefully we've got it. You can push pause and start and rewatch where you need to watch. Let me know if this helped, or if you need any other assistance with it. And any other time you need help, just let us know. Nice to talk to you tonight. Bye.